Okay, good afternoon, everybody. Thanks for joining me this afternoon. My name's Tom Scase. I'm one of the senior solutions engineers at BeyondTrust. And the next 45 minutes, I'm going to talk to you how you can actually enforce least privilege in a production environment, in an enterprise, and eliminate admin rights with endpoint privilege management. So if we first of all take a look at the modern endpoint and really the advances in malware, if we actually take a look at some of these statistics, we've got nowadays polymorphic malware, which is designed to change itself in order to evade detection-based technologies. We've also seen that, I used this in my session earlier, and also Sami kind of touched on it in his keynote this morning. The amount of new malware samples that are discovered every single day are unbelievable. The McAfee Labs, in their recent report in September, said of Q1 of 2019, there was over 67 million new samples found, and that equates to over 750,000, three-quarters of a million per day. Three-quarters of a million per day. And also we have the challenge of end users demanding admin rights to do their role of their job, and how many times you have to argue with a developer, an engineer, or even the members of the IT support teams, because yes, they do need to perform a large number of privileged operations as part of their role, but do they actually need admin rights themselves, or is it the applications that need those privileges? And actually, Sami put something on, but I could actually change that. The person who said this, I could change it to, Sami said it earlier, that it's ironic that people are actually always trying to identify the known bad, which is infinite. With those figures that you can see, it's pretty much infinite, when instead we could actually be focusing on the known good in the environments, which actually is finite. We can actually list those. And the Amon Institute, an independent researchers actually did a survey between 500 IT and IT security professionals, trying to understand where they were focusing their efforts within the organization. And from that, they created or built this hierarchy of perceived effectiveness. So if we have a look at the list of where they were focusing, this is their top 12, we can actually see that this contradicts the Australian Cybersecurity Centre, the ASCS, and other industry experts and compliance mandates in what they suggest that we should be doing as our top 4 strategies. And that includes application whitelisting at the very top, application patching, and then the operating system patching as the next 2, and then the reduction or reducing admin users. So this is what they're recommending. So why are organizations not necessarily following all these best practices or these recommended strategies? Yes, everybody is patching their applications and operating systems, but how many organizations out there are successfully implementing whitelisting? How many of those app blocker configurations out there are running within or running in active mode rather than just a passive mode? And why is everybody not just logging on to their endpoints as standard users rather than having local admin rights? Well, the reason behind this is because they're all perceived to be quite difficult to implement. They're not just easy security strategies like changing your AV, etc. These are actually going to have, or potentially could have, a detrimental effect on an end user's experience. And this is quite easily kind of described within this security compromise slide. And if we think of an endpoint that is 0% from a security scale, it's unsecured and unmanaged, how do we try and improve the security of our endpoints? Well, first of all, we'll start to roll out security policies and security products. Maybe we deploy group policies, antivirus, we've got network security, email filtering, maybe start to encrypt our devices. We then do as they were recommending to do our operating system and application patching. Maybe we're using tools such as SCCM to do this. Maybe we roll out patches to more high-risk servers, more app servers with a little bit more quicker, the high-risk ones. And maybe we can start to limit what the users can and can't do and what activities they can actually do on these devices and servers. And one of the ways that we could implement that is through whitelisting. So actually having that list of known trusted applications that are allowed to run, and then anything else that falls outside of that whitelist will be blocked. And then finally, let's remove those admin rights. So if we don't take away the admin rights, all of those other security controls that we've just put in place there can be disabled by that user. Now that would be great. We've now got a well-secured and well-managed endpoint, but as we know, this is not really going to work in an enterprise because users themselves expect the freedom to work on their work machine in a similar way to how they would at home. Maybe we just can't patch that server because we don't know what it does, and maybe that update is going to break that server. Users can't be restricted from doing their job. So if we're actually slowing down a user with the likes of whitelisting or taking away their admin rights, then we've got to weigh up the difference between end user productivity and security. And obviously we need to remain productive, and that's important. And for a user to be able to do their job, that might mean them actually introducing new applications, not necessarily apps that need to run with elevated privileges or need to be installed. If I'm a developer, I need to develop code. I need to test my applications. So we can't restrict them from doing that. And then finally, those admin rights that we've taken away, maybe we do actually have to give them back because someone does need to do them for their day-to-day job. The likes of the developers, engineers, those IT support teams that are regularly performing administrative tasks on their own and other people's machines. So I'm going to quickly now jump into a demonstration to show you how these security controls that we're talking about there, removal of admin rights and implementing whitelisting, can actually be achievable with endpoint privilege management. So this machine that you can see at the moment, imagine this to be a developer's laptop. They used to be an administrator on this machine because they have a demanding role. They need to perform lots of privileged operations as part of their day-to-day job. But we've highlighted that having a user logging onto an endpoint with an admin account is a risk. And that's because if I was to accidentally introduce a piece of malware onto my machine and I was running as a local administrator, then that piece of malware can also run in that context. It's got more access to the machine. It might be able to gain access to stored credentials. It could gain access to other areas on that desktop that, as a standard user, I wouldn't be able to access. And therefore, the malware couldn't access it. Also, if I'm an administrator on my machine and I'm not so technically savvy, then maybe I could break that desktop a lot sooner. Sammy mentioned that earlier today, that taking away someone's admin rights to think that the support calls are going to go up, but actually we're going to save those support calls where the user has done some form of misconfiguration. So it is recommended that we take away admin permissions to give you a more secure security posture. But unfortunately, as I mentioned before, it's not just the fact that the user said that they needed to have those privileges to do their job. There are genuine applications on the user's machine that could be considered business applications that do actually need privileges to run. So on my machine here, I'm logged on as my user. So I'm logged in as a user whose name is Stan. Stan is now a standard user. He was an administrator before, but there are many applications that just function absolutely fine, that launch without any challenge or any problems as a standard user. So the likes of the Office apps, the web browsers, Adobe readers of the world, they're not the applications that are a problem for us. The applications that are a challenge are the ones that do need privileges, and on my machine here I've got a number of applications, third-party applications that are installed, that now when the developer goes to run their developer application, maybe this is Visual Studio for instance, certain areas or parts of that application now trigger this Microsoft user account control message. This is the operating system telling us that this application or part of the application requires privileges for it to continue. But my user doesn't have admin rights anymore, so they can't make that change. Applications that I may have installed myself, whilst I was an administrator, now also challenge me with this UAC message that I can't put any admin credentials on to move further. And it's not just third-party applications. There's lots of areas of the operating system that also need privileges to make changes. So even something as simple as the power options. If I wanted to change my power options because it was annoying me that my machine goes to sleep every so often, I can't even do this as a standard user. So those are the types of things that I could have self-authorized previously as an administrator, but now I'm a standard user. Who is going to authorize that change? Who is going to launch that application on my behalf? So this is now where I need to get the service desk involved. A support call that wasn't necessary previously, that's obviously going to have a cost associated to it. And imagine that this user is actually not in the office. The support desk can't remotely connect to my machine. Maybe I'm at home, maybe I'm on the road. What if I do need to perform that privileged operation and I'm effectively completely offline? How are IT going to help me out in that scenario? They won't be able to. So luckily on this machine, I also have the BeyondTrust Endpoint Privilege Management product installed. So what I'm going to do now, without logging that user off, I'm just going to enable what we call our quick start policy. So the quick start policy is an out-of-the-box, production-ready policy, an enterprise-ready policy that we can actually just import into our product and then roll out into any organization. Any organization without understanding any of the applications out there that need the privileges, any of the applications that are unique to your organization, it doesn't matter. The reason why we can do this is based on the capabilities of the products that handle the unknown. So it's great that we can handle known applications, but it's probably more important of how we can handle the unknown applications, because there's a lot more out there that we do need to manage. So what I've done now, I've enabled what we call the high flexibility work style, part of our quick start policy. And the high flexibility work style is going to provide an admin-like experience to this developer that yesterday was an administrator, now they're a standard user that's being managed by the BeyondTrust Endpoint Privilege Management products. So what we're doing now, instead of giving the user the admin rights themselves, we're actually elevating the privileges of the individual applications. So the applications, whether it be an executable, control panel applets, management consoles, PowerShell scripts, installers, it doesn't matter, whatever that application is, we're applying the privileges at that level. So now when my user goes to make a change to the power options, for instance, this is a known application that the IT team is aware of that needs the privileges. So what we've done is we've put this onto a trusted list. So this application is just going to run seamlessly, elevated by the Endpoint Privilege Management products. So now when I click this, we see that the application just runs and the user can make the changes to that feature, that part of the operating system, as they would have done when they were an administrator. Maybe we've even reduced a step there where they previously would have had to put in their credentials based on that UAC message. We've actually simplified that process just by seamlessly elevating that feature. Now, the reason why that just ran seamlessly was because it was put on a trusted list. It was pre-identified as being an application that was trusted. But as I mentioned, there are also applications on this machine that could be unknown. And the way that we manage the unknown is using two capabilities of the Endpoint Privilege Management product. The first one is known as user account control interception. Probably one of the most powerful, in that any application that triggered that Microsoft user account control message, we can actually use that as an indicator that the application, for whichever reason, needs admin rights. So if it triggers UAC, we know it needs admin rights, so we can manage that application. But simply because it triggers UAC and it needs admin rights doesn't necessarily mean it's going to be an app that we do want to manage as far as IT is concerned. So what we do is we present the user with different forms of gated access message. And what I'm going to do now is show you a variety of those messages, the different types that we can display to the user. So here, for instance, my engineering application, there's nothing in my policy that's aware of this app, but simply because it triggers UAC and it matches certain criteria, we can manage this application. And here you can see one of my customized gated access messages. We can customize it with the company branding, logos, etc. So here I'm just using the PDS one because I'm at a PDS event. We can change the text. We can also change the language of these messages. So I could have a Dutch version of this message, and if the user's operating system language settings are set to Dutch, it will actually display the correct version language message. But here you can see this message box is the most simple message box for the user to authorize. It's asking the user that this application requires elevated privileges and it's not currently on a pre-authorized list. That's why we're getting a message, because it's an exception. And to ask the user to only continue if this is a business application and if they're happy to have their actions audited. And that's an important thing. Before, when the user was an administrator, the IT teams didn't have any visibility of what privileged operations they were performing in the organization on their machines, on other endpoints. But now we're going to audit everything that the endpoint privilege management product is managing on behalf of the user. So yes, this is an application that is a business app. I just click continue, and that application now runs with the elevated privileges that that application needs without actually knowing what that application was in the first place. A similar application on my desktop is my developer application. Yes, this one also triggers the user account control message, but it actually meets different matching criteria. This application doesn't have a valid publisher. So maybe it doesn't have, it's not signed by the vendor at all, or maybe in this case the actual vendor certificate has expired. So this, again, we're just intercepting the UAC message and we're presenting the user with a different type of gated access message. Maybe I'm asking them to jump through another hoop if they want to gain access to this application. And here you can see I've got a hyperlink in here. It's asking my user to go and read the corporate application policy, maybe a hyperlink to an area on the intranet. But as long as my user agrees to the terms and conditions, clicks continue, this application, which they've agreed is a business application, is allowed to run with the privileges that it needs. So again, this is, imagine this is an end user that used to be an administrator. They had the ability to self-authorize all of these previously. IT were not aware of what was going on, but every time we're seeing a privileged operation take place that the endpoint privilege management product is managing with the exception handling, we're going to raise an event. We're going to centralize that information so you as IT security get visibility of what those applications are that are running. Now, not all applications are UAC aware. So there may be legacy applications out there. There could be in-house developed apps. And in my environment here, I've just got a couple of applications which behave in a similar manner. Disk manager needs admin rights, and so does the firewall, but they're not UAC aware, so they don't trigger the UAC message if they're launched. So here you'll see if I just double click on this application, it runs, but it doesn't run correctly. So it doesn't run with the privileges it needs, and it gives me an error message. And it's the same for Disk Manager. No UAC prompt for us to automatically intercept, but I get an error message that the application's not functioning correctly. So with these types of messages and any other in-house developed or legacy application, an app that doesn't run as expected, all the user needs to do is use our on-demand capability. So the user account control interception will manage applications automatically that intercept the UAC message. But on demand, we simply ask the user to right-click. They've got an option in there, so I've replaced the run as administrator that would normally exist in that context menu. We don't have to replace it. You can actually intercept the original one, but here you can customize this message. And all the user has to do here, again, another variety or variation of the gated access message. That application now runs with the privileges it needs. Here I'm asking the user to reauthorize or reauthenticate with their standard user password. They could ask them to provide a reason, but the important thing is, without too much effort, that user can run the applications they require of their role, all under the context of a standard user account. So that was the end user experience for someone that was a developer, an engineer, and a member of the IT service desk that typically would be given an admin account. They no longer need an admin account anymore. They can log onto that desktop with a more secure standard user account, and with the EPM software running on the machine with a highly flexible end user experience with the quick start policy, they have the capability to run all of the tasks, the scripts, the actions of their role using that work style. Now, not everybody in the organization has an admin account. There's maybe more people in the business that actually run at the moment with a standard user account, the more secured account. But sometimes they find that they're having the standard user account is too restricted for them. But what we can do there is we can give them a little bit of flexibility back. So if you think of an everyday user, maybe someone who works in the finance team, the FD goes home one evening and he finds that his printer's broken. So he goes and gets a new printer from the local electronics store, drops the printer driver on the desktop, which is a Canon printer driver, and they want to install that driver. But this financial director is a standard user. So when that financial director goes to install, just drop that down to the bottom. So when that financial director goes to install that printer driver with our software disabled, what they're going to see, they're going to get that UAC message. So that's no good. But with the same endpoint privilege management product, I'm now enabling the low flexibility work style, which is a more secure work style, providing a more secure end user experience with some added flexibility back there. What this user can do is imagine that not only are they having a bad day with their printers broken, but they've also got no internet connectivity. So they've got no network connectivity back to the company. They've got no internet connection at all, so there's no way for us to push a policy down to this machine, and there's no way for the IT service desk to remotely connect. Now, obviously, that's going to be a problem unless you've got a product like ours on there, because this user can actually trigger the on-demand functionality. And what you'll see here is this message box that they're presented with is different from the others, because this message box isn't one that the user can self-authorize against. Instead, they're presented with this secondary authorizing message box. The secondary authorizer, as it says, it needs somebody else to authorize this privileged operation on their behalf. So in this case, what they've done, they've been provided with this unique challenge code. And this unique challenge code is unique to the user, to that application at that time. They can now ring the help desk. The help desk have access to this response code generator, and there's a shared key which is known by the service desk and also known by the endpoints, because it's part of the policy that's pushed down to the endpoints. And then once the member of the service desk has had a conversation with the end user, try to understand why they need to install this printer driver at this time or perform that privileged operation. If they're happy for them to continue, all they need to do is take this challenge code from them, so that can be read out over the phone, put the challenge code into the response code generator, and the unique response code can be relayed to the end user over the phone again. And then that privileged operation, even though that user is a standard user on the endpoint, they couldn't self-authorize that break glass situation themselves, but now they're able to perform that privileged operation even completely offline without any policy updates pushed to that machine. Yeah. Well, that's it. It's really the individual use cases. You can enable this feature within the product. If you imagine that the user, absolutely, you're trusting what the user is saying that they want to install. But at that time when they are completely offline, they're writing the event information locally. So the event information is being written to the event log, which will be forwarded to our enterprise reporting. So the IT teams will find out what they have installed. It's more for the remote user and that break the glass scenario. It's not a feature that you actually have to have enabled for everybody, but it's more as a just in case capability.
The person can tell over the phone that he is installing the driver, but he will run just CMD as administrator and just will remove all the policies.
They won't do that because we have anti-tamper protection in place. So there is obviously one of the things that you're doing there is you're putting trust in the end user for what they want to install. But as I said, if you can't trust your end users and you need them to be connected to the network, then absolutely get them onto the network for them to perform that privileged operation, and then the help desk can remotely connect in and actually watch them or kind of verify what they actually want to install. But this here is really for that true offline mode, a break the glass a break the glass scenario. It's not necessarily something that actually has to happen all of the time, but it just gives that functionality if you want it there. So what we can, so this is here, what you've seen there is really how we can actually give that different type of end user experience, whether it be someone that needs quite a lot of flexibility as part of their role, the engineers, the developers, IT service desk, where you would provide them with this admin-like experience, or anybody else that's maybe before as that standard user had those scenarios where they did need to perform a privileged operation every now and again, but instead of actually having to get the service desk to remotely connect in, we can now add a little bit of flexibility back. Even as this service desk or this person that's gets this challenge message every now and again, well, actually, even though they're getting that challenge message, maybe we can elevate things automatically for them. So maybe giving them the ability to do some privileged operations seamlessly, like elevating the actual properties of the adapter, or maybe giving them the same capability to go and actually change the power settings, the power options, just like the other people did. So, you can actually add that little bit of flexibility back, but also restrict what they can and can't do with the secondary authorization challenge message. So what we've looked at so far is all to do with the privilege management side, the taking away the admin rights and giving different types of end user experiences based on people's roles. But one other thing that's important that I mentioned and how we can reduce the attack surface even further is to actually implement whitelisting. The reason why whitelisting is important, because if I've just disabled, or I've just actually disabled the software, so I'm still just effectively now running as just a standard user, so there's the UAC messages back up. I don't need to be an administrator to introduce my own applications and run them on this corporate device. I, for instance, here can just launch this executable. It doesn't need any admin rights, doesn't need any installation, and it's just running on my machine. What's to say this executable wasn't downloaded from an unofficial website and it's something more malicious is not running in the background? We've also got applications that do perform installations but don't actually need to be installed into the default traditional locations. So this torrent application, if I run through the installation as a standard user and it asks me, do I want to install to program files? Program files and the Windows folder are both protected locations to a standard user. So if I tried to continue with that installation, it's going to challenge me for a UAC authorization, which obviously I can't do as a standard user. But this application, just like Spotify, Dropbox, Chrome, you can actually install them into the user profile area. So I don't actually have to install that application into program files. I can install it into my user profile location. So there's my torrent app running on my corporate desktop. And these applications are applications that I've knowingly introduced. But obviously it's important that the user doesn't accidentally introduce applications which can run on that machine that can also cause damage. And there we're talking about ransomware now. So on my desktop, I've got some content. So I've got a number of documents here. So you can see I've got my Word docs, my PDF reader, or PDF documents. And what I'm going to do now is introduce a piece of ransomware onto my desktop. And it's going to encrypt these documents. An obvious way for ransomware to come into an organization could be through an email. Maybe a phishing email has come through. It looks like it's come from a trusted source. And all it takes is one person to click on a link that opens up a web page or a web browser that may have some vulnerability in it. The web browser has been exploited. The drive-by download has taken place, dropped to disk this unknown executable, this fake Adobe executable. It's dropped to disk and it's gone and encrypted all my documents. So this ransomware, as Sammy pointed out before, you don't need admin rights for ransomware to run and to cause the damage that it does, because I, as a standard user, have the ability to delete, encrypt, zip up actual content as a standard user. So that's why ransomware is damaging across everybody that logs onto an endpoint in your organization, whether they've got admin rights or not. So here you can see my documents have been encrypted. The only accessible document is this one, or this link that's going to take me to a web page, tell me how I can pay the ransom. But what I'm going to do now is just switch on that same product. So first of all, just recover my documents so they're all back and accessible again. And what I'm going to do now is just switch on the same endpoint privilege management product. But what we've done now is we've enabled the whitelisting capability within the product too. So this same agent is responsible for whitelisting. And when we talk to customers about whitelisting, they typically say, yes, we've tried whitelisting, or we've got it, we've got app blocker switched on, but it's in a discovery mode, it's just in audit mode. The reason why it's not active is because traditional whitelisting is, number one, difficult to maintain. So we've got a list of all of the known trusted applications. Even Sammy's list, it was a list of known good, but then he may have to update that every now and again. What if we update an application and the SHA-1 signatures, etc. change? We then have to update the whitelist so that that new version of the application now runs on the endpoints. But also we think of who we're trying to roll out these, or who we're trying to enforce these whitelists on. Well, we've got users like developers who develop their own code. Are we going to enforce a whitelist to a developer and then block them from running the applications that they've just developed? So it's trying to find that balance. And the way that we do things differently with our whitelisting is, first of all, if you take a look at my whitelist, it's not a list of thousands of known good applications. Instead, I'm just looking for any executable, any path, any vendor that matches this property known as trusted ownership. So what is trusted ownership? Well, trusted ownership, here we're not looking for what the application is, where it's been installed, what the vendor is. Instead, we're just going to trust who has installed the actual application. So effectively, we've got a known good list of actual installer accounts. The easiest way to think of it is that if an application is rolled out by IT, it is owned by one of a small finite number of trusted owners. So those trusted owners will actually be one of these three. If you actually check on in your machines, it'll be trusted installer, the system account, or the built-in administrators group. If an application has actually been introduced by a user, a standard user, NTFS permissions dictates that the user will be the owner of that application. In other words, it doesn't match any of these trusted owners. The beauty of that means that you can continue to roll out all of your applications with the same methods that you've used previously. Use an SCCM to roll out new apps, update applications, etc. When they're pushed to the machines, they're installed with a true admin account, and that means that they're owned by a trusted owner. So they automatically match the whitelist. But then anything that falls outside of the whitelist, with traditional whitelisting like AppBlocker, it would block something. But we've just said there that that's going to be too restrictive for someone like a developer. So in the same way that we've got the exception handling capability with the privilege management product or privilege management feature, we can do exactly the same thing for applications that fall outside of a whitelist. For developers, we'll give them the ability to self-authorize applications that are exceptions to the whitelist. Yes, I can. This is an application that I've just developed. I will continue to run with that application. For standard users, the guys that are everybody else in the business that don't actually need to introduce their own applications, when they try and run something that falls outside of the whitelist, absolutely we can block the application. We can actually block it. We can integrate with ticketing systems like ServiceNow and Remedy, and the user provides a reason, hit submit. Maybe it integrates with the ticketing system, or we can just pre-populate an email on behalf of the user and they can hit send if they've got a genuine business reason for trying to use that application. But that there is the default deny, the most secure way of protecting your environment using that same method. So different roles within the business, different end user experiences. And then we go to that malware attack. Here if I actually go and click on that link now and we've got the low flexibility work style protecting this environment, if there is that vulnerability in the web browser and we jump in there and as soon as that binary drops to disk, that binary has been introduced by the user. So NTFS permissions will stamp the user as the owner on that executable, however it was introduced, whatever that executable is. So it falls outside of the whitelist because it's not owned by a trusted owner, and we blocked it. So that's a traditional attack. So that's traditional attack there, an executable drop into disk. That could be detected via AV potentially. It could be blocked by whitelisting that you've seen at the moment. But more advanced malware nowadays is actually starting to leverage whitelisted applications. Sammy pointed out that within the ransomware attacks, they're all using PowerShell. So if I am actually a developer, I use PowerShell on a day-to-day basis. So I use PowerShell. I also use Microsoft Word. So what happens when that user actually gets sent a phishing email that's actually got an attachment on there that's got a malicious macro in that attachment? So here, for instance, I've just got a very basic example here. There's a Word doc. The user is tricked into enabling the macro, and then that launches PowerShell, and it runs an actual PowerShell script, which then goes and does all the damage that a piece of ransomware could do. So there are two whitelisted applications. How are we going to protect against that? Well, this is where our trusted application protection comes into play. So trusted application protection is all about applying an additional layer of security to high-risk applications. And the high-risk applications that we consider are going to be the Office apps, your web browsers, and the likes of Adobe Reader. If you think of receiving a malicious document, it's typically going to be targeting one of those types of content readers. They've got lots of vulnerabilities in them, and they're used globally. So those applications, the Adobe Readers of the world, the web browsers of the world, they're harmless when they're used correctly, when they're functioning correctly. It's only when they're exploited and their child processes run that are unrelated to their function, whether that be a new executable that's downloaded from somewhere on the internet, an unrelated executable that could be seen as more of a trusted exploitable. We shouldn't see PowerShell run as a child process to Microsoft Word. We shouldn't see untrusted DLLs being loaded into Adobe Reader, for instance. And that's exactly what the trusted application protection will protect us against, the child processes running for these high-risk applications. So now when my user goes to run, or is accidentally tricked into clicking on the hyperlink here that opens up PowerShell or this script that runs in here, now what we've got is the trusted application protection, which has blocked that executable from running. So PowerShell has been blocked there because it is run as a child process to this high-risk application, but that's not blocking PowerShell from running that the user launches themselves. It's just got that contextual awareness. We can actually check that when a process runs, checking its parents and seeing if any of those parents are one of the high-risk apps, and we can actually put that block in place. And then in a similar way, if I go and launch the attack from before this launch, the web browser is considered a high-risk application. That then called Java. Java then calls the command prompt and then continues with the attack. But what we can do is before the drive-by download takes place, what we can do is we can intercept it slightly earlier and stop that attack from stop the attack from running completely. So here we go. If I just launch that again. So we are actually blocking it there, so I'm just not getting the notification pop up in the corner. So what we do there is where Java then calls command prompt is a trusted exploitable, so we're blocking that from launching. So before the drive-by download even takes place, we're actually stopping it earlier in the attack there. So one final thing I just wanted to touch on was the enterprise reporting, because if we are giving certain users the capability to elevate the unknown, elevate applications, task scripts that are part of their role, we want to give you visibility of that as an IT security perspective. So if I just do a quick refresh on my enterprise reports, we'll see during this session, the last 7 days, there's been 17 applications discovered. Only 6% of those needed admin rights, 94% of them ran as a standard user quite happily. We can see who's still logging on as admins. This project is all about the removal of admin rights. We can see the trusted application incidents being raised. We've got the anti-tamper protection, stopping users abusing this product to disable the product in any way. Maybe they try and add themselves back into the local administrators group using an elevated PowerShell prompt, but they won't be able to do that. And then here's where we actually find the exception handling capabilities, the UAC matches and the on-demand. If I go into the UAC matches, we'll actually see some of the applications that I used in my demonstration. Well, actually, I'll go back and go to the on-demand. So on-demand here, we'll see that we've got my printer driver that was on the desktop. We've got a process count there, a single process. We've got the user, the date, the device that they actually launched it on. And importantly, if I click on the information, you'll see a lot of the metadata that we can use to create application definitions. So we can look at things such as the publisher, the path, the application name, the command line, the SHA-1 hashes, who the owner of the application was. And there's other things in here like product name, product version, file version that we can use that's currently missing there. And that's because if I scroll down to the bottom, we'll actually see that that executable was just a self-contained zip that then actually spawned a setup.exe, which was the true printer driver. So here we've got more information. So we've got the product name, Canon utility setup, the version numbers, etc. And we can use this information to then add to trusted lists. So if that's an application that you're happy for users to continue to use moving forward, maybe we can put that onto a trusted list. So to show you how simple it is, I mentioned that we use these out-of-the-box policies, and the way that our policies are designed and created are typically loved by our customers in that it's a firewall-style ruling. We create application rules so we can elevate, allow, or block applications on these rules. These rules target application groups. So here I've got a blacklist of applications that I want to block. I've got an allowed list of applications I want to seamlessly elevate. So if I know of more applications that I want to seamlessly elevate, I can just insert those apps. We've got 14 different application types that we support, so there's an extensive list there. But down at the bottom here is the event section. So we collect events managing the unknown. We start with a very flexible end user experience for those guys that were admins and devs, etc. We can then see what they've been up to, and we can actually import the event information and actually go and target the applications that users have been running that have been considered exceptions. So here I can actually see the one that's on my desktop. So this application, this NT Lite application, yes, it was a very simple message for them to authorize against. They just click continue. But let's improve the end user experience because that is a business app. Let's just add that directly to the trusted list. We can go and change the application matching criteria if we wanted to. So am I concerned of what the file folder name is, or am I just happy with the product name matching and the publisher matching? So I can just say that. I can add child processes to be managed if I wanted to. Click OK. Pushed out that policy, and then the next time that user or any other user runs that application, they're no longer prompted with one of the messages, it just runs seamlessly. So this is all about showing you that it is actually possible to remove admin rights from anybody in the organization, however demanding their end user role is. It's not the user that needs the admin rights, it's the applications, the tasks, the scripts. And with a combination of the user account control interception capability on the on-demand and giving them the right level of, or the correct work style based on their role, we can absolutely enable you to remove admin rights to your end users overnight. So thanks for joining me this afternoon. If you've got any more questions, please feel free to come over and speak to us at the BeyondTrust stand. Thanks, everybody.